things that we'll complete today, and then we'll get into the doing one regression case. By the way, I hope that everybody has downloaded Nine, right?
Hello, sir. Good morning.
Good morning. Good morning.
Yes, sir. Request you to please do not change the meeting option, sir. It will affect on attendance.
What the meeting option?
You have made all presenter. Now I have made back
No,
all
no.
attendees.
Oh, acha, acha. Okay. Anyway, I don't remember doing that, but anyway, fine. No problem. Okay.
If you want
No, no,
student
no.
mic,
No, no. I don't need all present. I don't know how it happened. Okay, that's okay. But now
okay.
everybody is on the mute. Can I
Yes,
change them?
yes. If you want to unmute, just click on people's.
That's okay. So I'll allow
Next,
microphone. Okay.
yes, allow mic for attendees option
Oh,
is there.
okay. Okay. Fine.
Yes, sir.
Okay. Yeah. So so just wanted to check with everybody. Have you downloaded Nine in your laptops? Yes. No.
Yes, yes.
Okay. Great. Okay. So we will just quickly finish off the concept of regression, and then we'll also use a data set again. I mean, I think I had to made request some time back that if you have your own data set from your business, please share that with me because that will help you to identify the use cases and work on the data which is useful to you. Okay, otherwise the data that on which I'll be showing may not be relevant to your business. Okay, it will be a just generic data, so you need to then figure out where we are going to use it in your industry. So, but if you have a data from your company, if you bring that data, then it is this will be much more relevant. Okay, because as I mentioned that the data that is available in the public places are usually not data related to manufacturing industries. Okay, there are no data available in the public domain for manufacturing. Okay, so unless you bring your own data, you will not be able to work on a data that is relevant to your industry. Okay, otherwise it will be generic data for sales, marketing, and those kind of stuff. Okay, so if possible, bring your data, send it to me a few weeks in advance so that I can work on that data and I can show how it works, how all these models work on data that is relevant to you. Otherwise, the data will be something completely from other industries. So please bear that in mind if you can get some data from your company. So quickly, before we start Nine, uh, okay, so last session we were just talking about uh, this R square, and I had asked you a couple of questions. The first question is that can R square be negative? Okay, if you remember that, yes or no? Yes.
Yeah, we'll
Yes, sir.
discuss this now.
Yeah, yeah. So, and we were saying that R square theoretically can be negative if I draw a line like this. My regression line is this. Obviously, it's not the best fit line. Then what is going to happen is, um, if you look at y minus y bar squared, so the green part will be this part. green part will be this part, okay? And the red part will be this part. Red part will be this part. The red part will be bigger than the green part. Okay, so what is going to happen is that SS residual will be higher than SS total. Sum of square residual will be higher than sum of square total. So obviously this value will be greater than 1, and in that case R square theoretically can be negative. So it's just for theoretical understanding, nothing related to practice as such. But from a theoretical perspective, yes, it is possible. What is the lowest value R square can have? What is the lowest value R square can have? What is the highest value and what is the lowest value?
+1 and -1.
Highest value is +1. The lowest value is not -1. The lowest value is minus infinity.
Okay.
Why minus infinity? Because if my best fit line is the same as that of, not best fit line, but rather the regression line is the same as that of this dotted line, the mean line, then what is will become SS total will become 0. So theoretically, the minimum value of R square is minus infinity. Okay. And the maximum value obviously is 1, where the sum of the residuals is 0. Okay. Fine. So I think we will
But-
now take, yes.
Professor, but at that time, numerator also will be 0, no?
No, numerator
If,
will not be
regression
0.
line.
No, numerator will not be 0. SS residual will still become this your red line. Na? So if this is the the line, the regression line, then SS square will SS residual square will be this, because your the predicted y value is here, the red square. The predicted y value is this.
Okay.
But anyway, this is not of any practical application. It's just a theoretical one. Okay, so now I'm going to share a data set with you, and we are going to do a regression on that. We'll first use 9, and then we are going to use Colab Notebook. Same thing we are going to use in Colab Notebook, just to just to explain the fact that now you don't require, in most of the cases, any coding knowledge to write any code. Okay. Because with generative AI coming in, you do not require any coding knowledge. 95% cases or 99% cases, your coders are not required. You can do their job. Only in 1% case, where probably a very odd or a complex scenario, where generative AI is not able to solve a coding problem, which is very, very rare in especially this kind of standard problems. Only then you require a very experienced coder to help. If you have 200 coders, probably you require only 5 very experienced coders instead of 200. So that's a big, big change that is going to come to the, are already coming, in fact, to the IT department of any company, as well as the IT industry as a whole. Okay, so most of the coders will not be required anymore. So, and you will see that why I'm saying this, because I'm assuming that most of you do not know Python, or probably do not know any coding at all, and yet without knowing even a single line of code, you still will be able to do it on Python. Okay, so let me just get the data set. So just see if you have got this file. You're able to download it.
Yes, Professor.
Okay, great. So if you look at this file, and not related to your industry, a very simple use case. So we have this is where we're trying to predict the sales of a fictitious company based on the advertisement that advertising spend that this company has on television, radio, and newspaper. Okay. So it is supervised machine learning because you already have the past data about for a particular, maybe this is the data of specific months. In specific months, how much is the spend on television, how much is the spend on radio, and how much is the spend on newspaper, and then what is the sales of that month. So we want to know that if I have a specific plan of a spend on television, radio, and newspaper, what is the expected sales that I can expect? Okay, so that's a simple that's the regression problem that we're trying to solve. Now we are assuming that these are linear regression. That is an assumption. Uh, how do I know the assumption is right or wrong? There's no way. Only if you think polynomial regression is more fitting, you can probably know it a little bit from visually, but otherwise you have to experiment. You have to take different polynomial regression, and you have to figure out that which degree of you know which degree is most suitable. Okay, so usually if you have to do this way, the machine will iterate with multiple polynomial equations till and then come to a state where there's a balance between what is called bias versus variance. Okay, otherwise there is no way to know whether it should be a linear regression or it should be a polynomial regression unless we calculate the bias variance trade-off. We'll talk about bias variance trade-off later. So as of now, we'll assume that we are going for a linear regression. We will do both simple linear regression as well as multiple linear regression. Okay, what is the difference between simple linear regression and multiple linear regression? Anybody remembers?
The attributing factor is only one in simple regression.
Yes, that's right. So we have three features, but let's say we add one more feature which says total ad spend. Make this change, and I will add up television and radio and newspaper, and then if I try to predict sales based on total ad spend rather than spend on television, radio, or newspaper. In that case, it will be a simple linear regression. Otherwise, it will be a multiple linear regression. Okay. So let us do both. So let us save this file and let us go back to our 9 and we'll do this activity there. So you can open your 9 now. So let's just get little familiarized with the KNIME interface. So these are KNIME interface. So right now I'm not signing to the hub. We'll come to the hub later. So everybody is getting a similar kind of interface. Yes, no?
Professor, it's still at get started with KNIME.
Sorry? Oh,
It's
acha,
coming
so
as get started with KNIME.
okay. Fine. Okay. So once you get it, you will probably get this this kind of an interface. And for you, obviously, this will be empty because you have not used any workflows. So there are two places. One is called a local space, and the one is called a KNIME Community Hub. Okay, KNIME Community Hub is a small cloud platform where you can put your workflows. Workflow is nothing but a pipeline. Okay, so pipeline is a set of steps that you will do to perform the objective. In this case, the objective is to do a regression model. So important thing is that you should know what are the set of steps, because doing those steps. So what needs to be done is today more important, because how generative AI will do how part. We don't need to know how. We need to know what. So if I have to predict the sales of based on that spend, what are the things that we need to do? That is what is more important, because once you know that what are the things, then you will have specific nodes in this case to be able to do that. Okay. So that's called a pipeline, okay, or a workflow. That's why you see the workflows and the pipelines. Okay. And this can be done on a local space, which is your local drive, or it can be done on the cloud. So once you create an account in KNIME, it gives you a free cloud space where you can store your workflows or your pipelines. So for now, we will go to the local space and we'll do. Okay. So in the local space, you see it's just like a folder. So I can create a new folder here. For example, I can create a new folder like I can say, let's say, so I can create a new folder here, and this is where it will arrive. And when you create a new folder, what you see over here is three kind of sections. Okay. On the left hand section, you have the nodes. What are nodes? Nodes are small set pieces of code which are already pre-programmed and published by KNIME. So instead of writing those codes, you just pick up those nodes and you do what is called configuration of the node. That means you provide certain input parameters to the node that is required to perform. For example, if you want to, um, uh, let's say, read the file as the first step. Okay, read the file. So usually you have to write. If you know a little bit of coding, you know that there will be a command that you have to write in Python and R that will, like read.csv or whatever, that will ask the program to read the file from a specific location. Okay. So the problem is that we don't remember the command. That's why we get stuck. So here we already have a predefined node, which is to be used for the purpose of reading the file. Now, all that I need to do is to pick up that node and then only configure the location where it should read the file. Okay, and that will help me to to read the file without writing the code. Okay, is this part clear? Yes or no? All good?
Yes, Professor.
One thing is that I should not have created a file workflow here, because that's not what I want to create. I will delete this. I will create a folder because workflow is for a particular. So I will create a folder. Okay. And within the folder, we create a workflow, which is sales. So obviously now, even as I said, this whole concept of no code platform is also challenged because now you do not need to even do that portion of picking up the node. You can just write in plain English that I want to read a file from this location, and rest of the job will be done by generative AI to go to that location and pick up the file. Okay. However, what you still need to know is what are the steps that you need to do before to arrive at the solution. So the steps still needs to be known. However, as you can see that there is something called KAI, which is the generative AI of 9. So in the generative AI of 9, simple problems such as this, you do not even require to know the steps. Okay. If you tell the objective is very simple. I want to make a regression, or I want to predict sales. I don't even know that it's called regression. I just say that I want to predict sales based on advertising data. Everything else will be done by generative AI. So I don't even need to know what is regression. I don't even need to know how things are calculated. I just tell what my objective is. However, if it is a little more complex problem, it may not be so easy. But as we all know, generative AI is moving very, very fast, and gradually all these things will not be, I mean, most of the people don't need to know all of these things. Okay? Most of the people just need to know what they want to do. I just want to get a prediction of sales. That's all I need to know. I don't need to know how it is to be done. Okay. I just need to do what is to be done. Everything else will be done by generative AI. And obviously the people who will be involved in doing the how their jobs are at stake. Okay, anyway, but we are not yet there. So we just really need to learn this. So let's start doing this. So coming back to this question of predicting sales based on the data, what are the steps? What do you need to do? Broad. For the first, initially, we want to predict sales based on the total advertisement data. Okay, total advertisement. We want to do a simple linear regression. That means there is only one feature and one outcome. Tell me the steps.
First, we need to plot the graph.
Plot the graph.
Yeah,
of-
total sales versus the advertisement.
Plotting the graph will be the line, right? The regression line. That's the outcome.
Okay.
Or you are saying that plotting individual cells.
I was thinking x-axis versus y-axis. You will have a line plot.
Oh, plotting individual cells. Okay, plotting individual cells. Okay. But before that, where will you get that data? You have to read the data, right?
Correct.
In the line, in this line workflow,
We have to read.
unless
We have to
line,
extract
yeah,
the data.
unless line reads the data, how will the line plot? Okay, fine. So I read the data, then I plot the data. Then what is the next step?
Then draw the best fit line for the.
How? I mean, that's the one that I want line to do. That's the model. How do I get that line?
We have to apply a simple regression formula for this.
How do I know what is the best fit line? It's a trial and error, right?
Correct.
Okay. So what do I have to do?
We have to find R square error.
R square is
drawing,
first I have to ask time to try many lines. Getting the point? What is the process? I have to randomly draw the lines, calculate the R square for each of these lines till I come to a situation where the value of R square cannot increase anymore. Considering that I am doing a linear regression. I do not know what is the line. I do not know that line. I have to find that line by multiple trial and error. So I randomly draw any line, find out the R square, then move the gradient descent principle, move either to the right or to the left. Find out if my R square is increasing or reducing if I move to the right or left. And as long as it is reducing, I keep on drawing the line till I come to a line which is not from where R square cannot be reduced any further. Correct? Yes or no?
Yes, yes.
And we are calling that the best fit line. Okay. So that is what we have to do. Very broadly, at a very basic level. However, there is one more step to this. And this step is called training versus testing. What happens if I just take entire data and draw this line? This line has the highest value of R square and think that this is the best fit line. But what is my final objective? My final objective is not to predict the data which I already have. The data that I already have, already the cells is known. There's no question of predicting that, or there's no use of predicting that. So why am I trying to draw this line? If I already know what is the sales against the advertisement. Anybody? Why am I doing this exercise? Because I thought the data that I am using, I already know what is the sales.
No, based on the past data.
Yes, past data is with us. And in the past data, we already have the advertisement data and we already have the sales data. So what are you doing predicting the sales data? Okay, yeah.
That will give us the best fit line, which will help us to predict for the future.
Predict something where I don't know the sales.
Correct.
Correct? Yes or no?
Yes, yes.
But the best fit line has been built on past data. Best fit line has not been built on future data. Correct? Yes or no?
Yes. Yes.
How do I know this best fit line is also the best fit line for the data that is coming in the future? So just by finding the best fit line is not the end of the process. I have to take another set of data where the model does not know what is the sales. And I try to predict the sales based on this model and see how accurate it is. So how can I do that? I can do that provided I have a small set of data where I know what is the sales, but I don't tell the model the sales. I apply the regression model on this particular data where the sales is known, but the model doesn't know the sales. It's like an examination. So first you train the model. That means it's like a course, it's a class where you tell that this is the concept. Then you give a question paper. For a question paper, there is an ideal answer. The student will answer the questions. Once the questions have been answered, the student's answer is matched with the ideal answer. and see how well the student has answered. That is the testing. That means I need another set of data where I know what is the sales, but I don't tell the model the sales. I ask the model to predict the sales based on the model that has been built on the earlier data. And then see what has the model predicted and what is the actual sales. What is the difference? How do I find out the difference? Same R square. So it is more important for me to measure the R square of the test data than the R square of the training data. R square of the training data will always be high. But I have to see whether the same model has given a high R square for the test data. Only then I can use the model for the purpose of predicting the unknown. Okay. This part clear? Yes or no?
Yes, yes.
Now, obviously, we don't have the only data that we have is the past data. We don't have any more data. So with this data, we have to do both these things. That means we have to train the model as well as to test them. How do I do that? So obviously, I have to split the data, divide the data randomly, and take a percentage of the data, let's say 70%, and use it for training, and remaining 30% use it for testing. A very important concept of bias versus variance will come up, but we'll talk about that later. Okay. So if this is the overall flow, so for you, what is important is you must know the logic and the steps. How to do it? As I said, in 9, it is drag and drop. With generative AI, it's even easy. You just have to write one line that gives me a equation. That line in plain English, even if you don't have to write in English also, if you write in Hindi or in Tamil or in Bengali, then also it will. You don't need to know anything else, at least for this kind of small problems. Not a single line of, but the concept, the flow is very important. Okay. So let's do this online. Okay. So first is, and then we'll do it on Colab Node. So first is we'll read the file. So we just the one problem is that we don't know what to search for. So this is where you have to be a little aware of what are the nodes. So these are called the nodes. What are the nodes that are being used? And over a period of time, you'll get used to it. But as I was saying again, that with generative AI coming, even these no-code tools are becoming irrelevant, because if I'm able to generate this entire work by just writing one line of simple English, okay, why would I need to do all of those things? So in the entire IT ecosystem, the no-code tools are actually becoming irrelevant today, okay, because of advent of generative. But again, some companies still use these no-code tools. So that's why I'm still teaching you, so that if the company is using no-code tool, you are familiar with how it works. But over a period of time, these no-code tools also will die. Okay, there's no relevance of these tools anymore. So we will just read the file. Okay, so I think this is a CSV file, depending on what file type it is. Second, set. Yes, it's a CSV file. So we'll use CSV reader. Okay. So these are CSV reader, and you just drag and drop it over. Now we need to configure. So you see this node consists of few things. One is that there is an input and there is output. Now this usually the reader is the first node because it's the first thing that you are doing. And that's why you see that there is virtually no input to this. Okay. But there is an output. Okay. So CSV reader output will be used for the purpose of uh, for the next stage. Okay. And in the top, you will see three buttons. One is a play like button, which is basically executing the node. So when you execute the node, it will do what it's supposed to do. Then there's a cancel and there's the redo, undo. And here down below, you have three buttons, three lights, red, amber, green. Red means that there is an error, or it is not yet configured. That means the node cannot run as of now. Either it is not configured or it's not configured correctly. And yellow means with and that can be warning sign also that it is configured. And if there is an exclamation mark, that means that it is configured, but there is possibly some warning. And then the last one is green, which means that it has run successfully. Okay. And here, if you have to configure, then right click and go to the configuration. Everybody clear so far? Are you able to see a pop-up which comes up for the configuration? Yes or no?
Sir, Saurabh here. I'm not able to come onto this complete window. Means I have just recently installed, so it is coming. This window is not coming, sir. The complete one which we are showing.
Send the screenshot. Where have you sent the screenshot? Yeah, where did you send the screenshot?
Yes, sending, sir. Just a minute.
Okay. Okay. So while Saurav is sending, let's go ahead. So what we need to do, so this is where the configuration is. And once you have done this activity, the output will be shown in the window below. Okay. So this is where you will see the output. So let's do the configuration. So if you right click and you configure, the first thing, are you able to see the configuration window? Yes or no?
We are able to see.
Oh, great. So you see there is the option of read from local files. So obviously in a real scenario, you will not have your files in your laptops. So there will be certain servers where your files will be there. So NIME can even connect to your servers or any other cloud ecosystem. And from there you can read the file. But as of now, we are just taking it from the local file. And then we're just saying browse. And we'll just go to the specific folder where the data is stored.
The screenshot shared.
Uh, I'll just have it. Okay. So after this step, I'll just start. So I have read the file, and you can see that there is a preview of this file. And but there are many other settings, because in the interest of time, I'll just, I mean, it's not possible to go through all the settings in the course, because then you have to be a NIME expert. Okay. So and there are obviously that each of these products, they have specialized people uh, who are experts in these areas. So if you have to do, let's say, implement any machine learning project on NIME at scale, you need people who are experts in time in that. So this knowledge of NIME will not be sufficient for you to implement that. This is just good enough for some this kind of toy use cases. These are all toy use cases. So in real life use cases will be much more complex. Okay. So obviously you cannot implement those unless you have sufficient expertise in those areas. So this is just for getting an overview. So there you need that. So that's why I'm not getting into all the configuration. So somebody who is a NIME expert will know the configuration in and out. But few things are important. For example, if you go to the transformation, one important thing is the data type. Okay. What is the data type? What is the type of the data or the format of the data? You can see all the data are numeric data. Okay. Now a question to you: Can I uh, have categorical data for prediction of a numeric data? My question clear? Can I use a categorical data? Everybody is aware of what is a categorical data and what is a numeric data. Yes or no?
Yes, yes.
So can we have a categorical data to predict a numeric data? For example, let's say I want to predict the income. And so there are various inputs. One of the inputs is, let's say, gender. Gender is a categorical data. Okay. So can I use gender to predict income, which is a numeric data?
Now we can
Using
convert that into numeric
using
and then
regression. Sorry. Yes. Sorry. Go ahead. You're saying something.
yeah, we can convert categorical into numerical and then use it in the prediction.
The first answer is that categorical data cannot be used as is to predict a numerical data. Okay. We'll look at
Yes.
what is the solution. So what you're saying is the solution. Okay. But first thing that we are saying, categorical data cannot be used for predicting a numeric data. Correct? Yes or no?
Yes, yes.
Yes. Why is it so? Why is it that categorical data cannot be used to predict a numeric data in regression?
Actually, regression is nothing but summation of errors. So categorical data cannot give the error.
Even before summation of error, regression is nothing but the equation.
Yeah.
It's an equation. Equation cannot be on a categorical value.
Yes.
Y equal to mx plus c. That's an equation. Whether that is giving the summation of error is high or low, that's to just figure out what is the best equation. But in regression, the first thing is that we have to form an equation. Correct? And I cannot form an equation unless all the data are numeric. So by itself, categorical data cannot be used for regression. But then what is the solution? We have to figure out a way by which a categorical data like say gender, male, female, etc., is converted to a numeric data. So how do we convert a categorical data to a numeric data if there's something like a gender? Anybody knows? You said, somebody said,
Assigning,
right?
binary
Yeah.
values.
Yes, yes, please. Go ahead.
Yeah, by assigning binary values,
Like male
0,
and
1.
female?
Yeah.
0, 1. Okay. So if I give a binary value 0 and 1, that will create an equation that will be an incorrect equation. Why incorrect equation? Because essentially you're giving, let's say you're giving male as 0 and female as 1. You are giving an inherently higher value to female, to the input values of female. Y equal to mx plus c, if let's say assuming that gender is the only factor on which the salary depends, what is going to happen? X with values 0, if it's male, the value of y will become c, and with the value 1, if it's female, the value of y will become c plus m. So c plus m will be greater than c. So inherently the salary of women will be shown as higher than the salary of men. So we cannot give a value 0 and 1 to a categorical value. We have to find out some other method. Anybody knows what is that method? This method
ANOVA.
is called, yeah, sorry?
ANOVA.
No. ANOVA is another technique to find out analysis of how it varies. Here we are not talking about how the variance is. We are talking about how do I replace a categorical value with a numeric value. Because we know that unless I can replace a categorical value like a gender with a numeric value, I cannot do a linear regression, or I cannot do a regression, because regression works only on numeric values. And the solution that one of you mentioned was I will make male as 0 and female as 1, or vice versa. And I said that this is not going to work because it will bias the value in favor of that category which has a higher numeric value, which has been assigned a higher numeric value. So if female is assigned a higher numeric value than male, then the female salaries will be always be shown higher than the male salaries. So what do I do with these values? Okay. So there is something called one hot encoding. One hot encoding. Has anybody heard about this? Because I understand why I'm asking is because I understand that some of these things, I think in the earlier class we mentioned, has been regression has been covered a little bit on statistics. So just I want to know which are the ones that has been covered, which are the ones that are not yet covered. So is something called one hot encoding known to you? Yes or no? The term familiar? Yes or no? No, very quiet.
One hot encoding was there covered in Foundations of Data Science.
Okay. So what do you do in one hot encoding? If that is covered, then you should be able to.
I'm unable to recall. So
Okay, no problem.
You encode categorical data into 1 and 0, right? That's the
professor got disconnected, I think.
Hello.
Yeah, Saurabh.
Yeah, Rajesh. Can you just guide me or where to go from here? I have opened
Actually,
this
when
nine.
when I opened, I got in the home screen examples: combine, clean, count if, and
Correct.
sum if. So there I
Yeah.
clicked on the first one, combine, clean, and okay.
Okay. Combine clean and
So
this one. Na? I'm also over there only.
okay. When I click, I didn't click on that. 1 second, what I did.
Combine clean and this thing only I'm there. So we means shall I show you my screen?
1 second, which one I clicked? I'll tell you. The home screen.
Sorry, no, somehow I was logged out. Okay. So how much did you hear? I mean, somehow I got logged out.
No, we were talking
You're
about
asking
one hot
about one
encoding.
One order. So we are done, right? We are done with that. Okay.
No, actually, we were trying to recall what was it.
Okay, we're trying to recall, and then I think okay. So one hot encoding means that instead of giving a value 1 to female and giving a value 0 to male, what you actually do is you create two separate features. One is that is the candidate male, and the other is the candidate female. So there are two separate columns. There is no column called gender. There is one column is the candidate male and the other column is the candidate female. And then you say that if the candidate is male, you give a value 1 to the column is the candidate male and a value 0 to the column that is the candidate female. And similarly, if the candidate is female, you do the other way. That means you make the value of is the candidate male 0 and value is the candidate female as 1. So this way, if you do, then there'll be no bias towards that that attribute that has a higher numeric value. So this concept is called one hot encoding. Why is one hot encoding? Let's say there are 5 different values, 5 different possible. Let's say I'm talking about, let's say something like city. So people coming from 5 different cities. Okay, and I'm trying to predict the salary on that is one of the input features. So in that case, there'll be 5 different columns. And a person can come from only one city. So one of these values will be 1, rest others will be 0. That's why it's called a one hot encoding. Because one is hot, the others are cold. One being hot because that means electricity is going through that typical circuit concept, and the others are 0. Okay, so far fine, everybody?
So
Yes
it will
or no?
increase the number of
It will, of
attributes.
course, absolutely. It will increase the number of attributes that leads to some other problems, which is called sparse matrix and all. Okay, but we will talk about that as we go along. Yes, of course, that makes the computation more intensive, but that's the only way to handle categorical values for regression. Okay, but for this case, we have only numeric values, so we are free from all these problems. We can straight away proceed with the numeric value, and we have read the file.
Professor Saurabh here. I'm not able to follow actually. So I've shared my screenshot. If you can just guide me.
Yeah, but I do not know from where you got this, because unless I see your screen, I'll not be able to figure out. Yeah, I saw your screenshot.
Actually, because we are opening it for the first time, it shows as an example screen.
Okay.
So when we click on the examples like combine, clean, and summarize, or any of the 3, there are 3 icons actually. This screen is coming.
Okay, so you are not able to open a new file.
No, actually,
Okay, then you have to share your.
just a minute. It's not allowing me to share the screen. Only meeting organizers and presenters can share. So I think the presentation access I will be needing.
Yeah, so the reason why it is happening is the moment I open your screenshot, I try to close it. I'm being logged out. So you have to share your screen, but I don't know whether you're allowed to. You have the access to share your screen.
No, actually, you need to provide me the access as a presenter.
Okay, so that will do that. How do I do that?
You have to go to the
Right-click.
people
Okay.
and next to Saurabh's name,
Yeah, 1 second. Make a project. Okay, fine. So now you can show the screen.
Yeah, this is my screen. Can you see my screen?
Yes. Go to the home. See what- Examples. Okay, go to the local space. Now you create a folder. Create a folder. Yeah. Go to the folder. Click on the folder. Yes. And click on the folder. You should be able to click on the folder. You want to go inside. Yeah. The folder is empty. So now you say add files.
Shall I add a file here?
Uh,
right side plus symbol is there, no?
plus symbol is also there. Oh no, this is not add a file. Cancel. I did not see the plus symbol. Where is the plus symbol? Yes, state work. Yes. There you go. You search for read CSV on the
This one?
top left. CSV, so you're already there, but otherwise you can search. Okay, so just drag and drop it into the.
Yeah.
Then right click and then you can start. Okay.
Okay. Yeah. Thank you.
Okay.
Got it. Thank you.
Yeah, no problem. Okay. So we were doing the configuration. So here you can see that I just checked whether all the data types are numeric, because if the data types are not read as numeric, then we'll not be able to build the regression model. So here it has read correctly as numeric. So we are done with it. Okay. So we'll just now execute this. And once you execute this, you see that data has been read over here. Okay, so far clear, everybody? Yes. Now, you will also see some basic statistics. For example, one of the very important things is whether you have missing values. Because before you do the data, you have to prepare the data for any kind of this machine learning problems. And one of the things that you need to take care of is whether the data has missing values or not. And if there are missing values means that for a particular row, you don't have, let's say, the data about the radio spread. For a particular month, for some reason, the data for the radio spend did not come. It's not zero. It did not come. Okay. It did not come uh, to the people who are maintaining this data set. It's very, very common, missing values. Okay, so if you have missing values, then there is a problem because you need to do something with the missing values. Because if the missing values is not treated, then the model doesn't know what to do with the missing values. Okay, so this particular data set is a fairly clean data set. So the missing values is there's no missing values. So as of now, we can ignore that. Okay, then you have this. Things like what are the in number of unique values, what are the minimum value, what is the maximum value, 25% quartile, 50%, 75% quartile, mean, etc. Okay. So this gives you a statistical analysis of the data that we have got. Okay. So far, fine. This is the first step.
Professor, I think
Yeah.
default column selection for us when we executed it, only there are 4 columns. TV,
4
radio,
columns.
newspaper, and sales.
Yeah, so because I added that in the Excel file, I added that. Okay. You can also do that
No,
because I
all these
added
missing
the,
files, minimum, maximum, all these things are not there.
in the statistics.
Yeah. Here you have many columns here. No, 14 columns are there.
Right.
And 5 rows. In my
Right.
case, it is showing as 200 rows and 4 columns.
No, you are seeing something else there. Because it cannot be
Oh, sorry, I was in
200.
table. Sorry. I was in
200
table.
rows is the, yeah, you are seeing this.
Correct. Sorry.
Yeah,
I got it
no.
now.
Okay.
Yes.
Fine. Okay. So now, our first job is to do a simple linear regression where I'm going to predict the sales based on only ad spend, not TV, radio, and newspaper separately. So what should be the next step I should do? I've read the file and my objective is to predict the sales based on only ad spend. What do you think would be the next step?
Next step is plot this.
Yeah, but before we plot, we have to tell the system somehow that I don't need TV, radio, and newspaper. I only need ad spend and sell. So for this exercise, the TV, radio, and newspaper, these 3 data are not important for me. Correct?
Correct.
Okay. So I have to go step by step. Okay. Because here I have to instruct the individual steps to the system and create a pipeline. Okay. As I said, in other methods where we'll be using generative AI, there I don't need to instruct or give so many steps. But in this process, we need to give the steps. So I have to tell that, look, in this particular exercise, all I need is ad spend and sales. These are the only 2 values I need to work on. Rest of them are immaterial, are not relevant for this exercise. So normally in Excel and all, you do something like hide, you hide the column. So here we will use something called column filter. So I will filter the columns that I don't need. So I will search for something called column filter. Here you see column filter and I'll drag and drop the column filter over here. Oh, sorry, not table, that's something else. It's column filter. So, everybody is clear up to this? Yes, no? All good? Yeah, everybody fine? Yes or no?
Yes, yes, Professor.
Okay,
Just
great.
added now column filter.
No, not a problem. So, but then I have to connect. So this is the output and this is the input. So I have to connect the output to the input. Only then this particular node, okay, which is supposed to filter the irrelevant columns, it will be able to do its job. Okay, so my first job is to connect. So all that I do is to drag and drop this to connect. Moment I drag and drop this to connect, you see that this has become yellow because it has by default on the right hand side you have column filter, but if you're not getting this, you can also right click and go to configure. Okay. Right click and configure. So I'm getting it on the right hand side. So here it says that it includes all the columns. By default is including all the fields. But I say that I don't need all of these fields. I just need only add spend and sales. So I am removed all of these and I just say apply. And when I say apply, now if I execute this, I've left with only two columns, add spend and sales. Okay. So far fine, everybody? Okay, the next thing that some of you are saying that I want to visualize the data. That means I will not be able to draw the line, because drawing the line is what exactly I want the model to be built. I cannot draw the line the way I have drawn the line in a sheet of paper. Here, I have to ask the model to try out various lines and arrive at a line which is the best fit line. But that only the algorithm can do. I cannot do it manually. All I can do is I can plot the individual ad spend points with the sales. Just to get an idea, why should I plot that? I should plot that to figure out if at all linear regression makes any sense. If there is too much of variation, then probably linear regression will not make any sense. Okay. So what do I do to plot? So I can use a scatter plot because both are numeric values. So I can use a scatter plot. And I take this output over here. And I'm going to draw a scatter plot. And the x-axis is ad spend. By default, it has taken. If not, I can always change it. Because ad spend is an independent variable and sales is the dependent variable. So y-axis is the sales. We don't have anything in the color and we can create a scatter. Clear? So far, yes or no? This is just to feel. That's why I did not draw it in the main workflow, because in the main workflow, this will not have, or main pipeline, this will not have any input. As you can see that there is no output from the scatter plot. No output node from the scatter plot. So nothing goes from the scatter plot into another plot. So this is just to get an idea that whether linear regression is good enough for the data or we should go for polynomial regression. Okay. So far fine, everybody? Yes or no? Run this. And we see that we can make this bigger. Open in new window. Are we able to see a new window that has opened? Yes or no?
Yes, sir.
Okay, great. So you can see the plot is there's a scatter plot which says the ad spend by sales, and we can see that the relationship is more or less linear. So we are sure that yes, a linear regression seems to be will appear to work, will work. Okay. So that's the whole purpose of drawing the scatter plot. Okay. But now we have to draw this line. This line we don't know, and this is where we have to use the machine learning model. Okay. So to draw the line. So let's draw the line. Slightly dramatic because 1 second. I need to- Mm. But I'm just trying to find out where to close the window. Seems to be taking the entire screen. So,
Professor, we are unable to do the column filter. Can you show me how it works?
sure, I'll do that. Just give me a second.
In our case also it is like that. It is full screen, unable to close it.
Okay, yes. Some of these things are quite. 1 second, I just. Full screen cannot be closed. Stuck. No way but to close line altogether. Yeah. So I had to force close 9 because whenever there is a pop-up, so let's not try and use the full screen mode because It creates a problem. It again. Yeah. So CSV reader. Yeah, so you are asking about the column filter, right? Are you with me?
Yes, sir.
So go to column filter. So first connect. You have to connect it, otherwise you'll not get. Okay. And then on the right hand side, or you can right click and get to the configure. You will see that it says includes all the fields. Okay, so I just need ad spend and sales. So I'll just
Sir,
Professor,
in my
for
file, ad
can
spend is
you-
not coming.
ad spend you have to add. Okay, ad spend is not there in the default file. Okay, so you have to calculate that in Excel and then import the file.
Professor, can you add instead of ad spend other one? Some TV or radio?
Yeah, that I can do, but then first I'm doing linear regression. You just add in the Excel file. It's just a simple Excel addition.
Okay.
Go to the Excel file, insert a column and add an ad spend. Sum of TV, radio and newspaper. Got it?
Yeah, Professor.
Because we want to do a linear regression where we want to see the simple linear regression where we want to see the impact of overall ad spend on the sales. Then we'll do a multiple linear regression where we'll see the impact of individual television, radio and newspaper. Okay, so far fine, everybody? Shall we proceed? Yes or no?
Yes.
Great. Okay. You can also save this. Okay. So this is what we got. And then we also did the scatter plot. That's where we got stuck. Not a part of our main workflow. We just want to check whether it is the linear relationship. I think it's better to expand it like this rather than, okay. So it's a linear relationship and appears to be a linear relationship. So we should be able to use a simple linear regression. Okay, so far fine, everybody.
Yes.
What would be the next step?
So line we have to start plotting.
Yeah, but we can't start plotting manually, right? We have to ask the algorithm to start plotting.
Yes.
So we need to have the algorithm learn. What is this process? This process is learning. The algorithm will learn. That means the algorithm will randomly create a line, find out the R square, see what is the value, then move the line left or right or clockwise or anti-clockwise, see if the R square is moving up or moving down, and then go on doing it till it has reached the maximum R square value. So this is the learning process. We have to make the algorithm learn from the past data and find out that line. But before I ask the algorithm to learn, I need to set aside a data on which I'm going to test. Remember, there's a training and testing. Yes or no?
Yes.
Okay. So I need to set aside a data which I will use for testing, where I will not provide the sales data. I'll just provide the ad spend data, and the model which has been trained on the second set, it will predict whether it will predict the sales, and I'll figure out whether the line that has been drawn on the training data is also applicable in the test data. Correct? Concept clear, yes or no?
Yes.
So before we ask the model to train itself, I must partition the data set because we don't have any more data. So this data itself, a part of this data we have to use for training, and the remaining part we have to use for testing. Okay. So we will have a partition. So we will use this table partitioner. And in the table partitioner, we will decide whether we want to have a relative or an absolute. Relative means I can say 70% of the data for training. So the one that I'm mentioning will be used for training, or is the first node, and the remaining one will be the second node. So 70%, if I say 70% will be 70% of my data will be the first partition, and remaining 30% data will be the second partition. The first partition data I'm going to use for training, and the second partition data I'm going to use for testing. Okay. And so I can do it for absolute. In absolute, what I'm saying is that my number of rows for the training is fixed, and remaining rows will go for testing. But here, of course, we are going to go for relative. Okay. And then we are saying that there are different types of partitioning, sampling, because essentially I'm doing a sampling. Which 70% will go to training and which 30% will go to training. So it's a sampling. So in this case, we are going to do a random sample. That means we'll take any data and put it into training, and any data will put into testing, such that there's a 70-30% split. But there'll be certain cases where we need to do what is called stratified sample. Okay. We'll come to that later. And then there's something called random seed. What is this random seed? The random seed means that every time I run this pipeline, because I've chosen random sampling, any set of data can go to any 70% of the data can go to training, and any 30% can go to testing. Correct? So there is no guarantee that if the second record goes to training when I'm first time running the pipeline, the same second record will go to training second time as well, because it's random. The second time, the third row may go. What is going to happen? Every time I run the pipeline, the model is going to get trained on a different data set. The model is going to get trained on a different data set. And that will obviously, I'll have different models for different purposes. Okay. Now, that way I'll not be able to
Professor,
determine. Yes, yes.
we are not getting I am not getting table partitioner.
Okay.
There's a table splitter is there.
Okay. This problem is because I think you have a different version. So I'm not very sure. Later on, I'll check that from where did you download, because ideally you should be having the same version as I am having. Okay, because this problem is because you are having a different version, because ideally Did you download it from the link that I have given, or did you download KNIME from some other place?
No, this is a Bosch freeware. So
Okay.
from there,
So I
whichever
think,
the latest
yeah.
version is.
Yes, yes. So I think there is a difference in the version which you are using and the version that I'm using. Okay. So that's why you're facing this problem. But okay. I mean, after some time, probably will go. So whenever you're facing this kind of problem, you just try to figure out that there would be somewhere else. So you need to get used to all kind of software. So once you
Is
get
the
used to
table
software,
splitter, is the table splitter and partitioner same, sir?
should be same. Okay, try it out. Okay, should be same. Okay, see, the best way to do this is to try it out. If it's different, it will tell you it's different. Okay, just show the screen, because these are all due to difference in version. Okay, I think you have a slightly lower version. That's why you are getting this. So
But
just
that
share the
options
screen.
is that option is
Yeah.
not there. That 70
No,
30 splitter is
no,
not there.
just share the screen. Who wants to share the screen? Anybody? Yes. Just search for partition. No, just don't say table, just say partition. Don't say table, just partition. Mm. Table splitter is different. Table splitter is a different. And not getting anything on partition. Okay, just search for table. What is the other one that apart from table splitter, did you get anything?
Table cropper is there.
No, those are
Updater.
it will not work. Should be something like a partition. I don't know which version it is. Yeah, column filter, table splitter is the one that you're using, right? Just no, wait. Close it. Close the dialog box. Remove the scatter plot or bring it down. Bring down the scatter plot. No. Bring down the scatter plot, not this one. The scatter plot. Connect the column filter to the table splitter. Connect the column filter, output of the column filter to the table splitter, not the scatter plot. Yes. Connect that to the table splitter. Yes. Go to the configuration. No, this is not the filter. This is not the partitioner. Okay. Let's do one thing. We'll proceed. You figure out. You have to probably go to the help and figure out what is the node which is doing the partitioning for your version. Now it might take a little bit of time. You have to go. Yeah, you have to go to the guide and find out what is the node that is being used. Just search partitioning. How to partition table or something like that. Okay, I think you try out. No, it may not be called table partition in your version. It may be called something else. Yeah, so that's why you're not able to find out. So table partition this thing is not there. So let's leave it. Okay, you take it as a, because you need to figure out in your version what is the equivalence of partitioning. Okay, it may be called table partitioning or something else. Okay, so that you need to figure out for your version what it is. Otherwise, you have to download this version from the cloud and use it. Okay, but you should be able to figure out, because in the documentation it should be given that what is the what is the node that is being used. But do that no, maybe later on so that we can proceed. Okay, so we need to connect this. Okay, and is everybody clear about what we did with the the what we did in terms of the partitions that we created in terms of the random sampling and all? Is everybody clear about that? Yes or no? Okay. So here you see that there are two partitions. One is the first partition. The top one is the first partition. Okay. And the second one, the bottom one is the second partition. The first partition has 140 rows and the second partition has 60 rows, because we have said that 70% of the data should go to the first partition and 30% of the data should go to the second partition randomly. Okay, why randomly? Because we do not want any specific bias. Let's say top 100 will go to the training and bottom 40 will go to testing, something like that. It should be randomly picked. But at the same time, did you understand that what is the purpose of using what is the purpose of using this fixed random seed? Was this is this clear to you? Yes, no?
No, sir.
Okay. So what do in a random sampling? In random sampling, I have 10 records, 1 to 10. I'll pick up any one of them. So I may pick up 2, I may pick up 5, I may pick up 7, I don't know. Correct? This part clear? Yes or no?
Yes, sir.
Okay. So what will happen every time I run this sampling process? One time I may get row number 2, row number 5, row number 7. Second time I may get row number 1, row number 3, row number 10. So every time I run this pipeline, I will get a different set of values for each of these nodes. This part clear?
Yes, sir.
Now what my objective is? My objective is to get the model trained on a set of values. If the set of values changes, the best fit line will also change. Yes or no?
Yes.
Okay. So that means every time I run the training, the training run, I will get a different, let's say, different best fit line, depending on what is the set of values on which I am getting the model trained. So every time I'll get a different set of regression line.
Yeah.
Is this part clear? Okay.
Correct, sir.
Now if I do that, then I don't have, I don't know which model I should work on to predict. So what I'm saying when I'm saying fixed random seed, I'm saying that even though you're doing a random sampling, every time you do a random sampling, let's say the first time you've decided to put row number 2 on the training data set, every time you do a sampling, you must put row number 2 in the training data set, not once in training data set and another in test data set. So then every time my model is going to change. That is what is called fixed random seed, and I can give any seed what will ensure that every time the same set of data will go to training and another set of data, fixed set of data will go to testing, even though this set of data has been drawn in random. Okay.
Understood, sir.
So far fine, everybody? All good? Shall we proceed?
Yes, sir.
Okay, great. So now that we have got the training and testing partition, so top one is training. This is the one where I'm going to train the model on. This is the testing. Okay. Now I need to create that learning system. So I need to get what is called linear regression learner. This is the linear regression learner. This is the model. This is the node that is going to get trained on the existing data set. And the output will be a trained model. What do I mean by trained model? The output will be an equation. And then this output is going to be tested on the other data. That means the output will now predict the sales for the other data set without knowing the sales. And then I have to do a comparison. That how far the actual sales, it is there in the test data set, differ from the sales that this particular model has predicted. Is this clear? Yes or no?
Yes, sir.
So I'll put this here. Let's see what configuration I need to do. So I have to define, so it is reasonably intelligent enough to figure out what is the, both are numeric values. So it knows that what is the target and what is the features. So it is saying that the target is sales. It is automatically figured out the target is sales and the feature is ad spend. And it is correct. I don't have to do anything with it. But in case it was not able to figure out which is the target, which is the feature, I would have to change this and do it in a different, change it accordingly. In this case, it has been able to figure it out clearly. Okay, so it is fine. And there are a few other settings, fail on observing missing values. So it's saying that, okay, I can also say ignore it. Though there are no missing values here, I can just say ignore rows with missing values, so that if there is a missing value, the entire training doesn't fail. Okay, apply, and I will now run this. This is the training. Okay, so now you see that if you go to the training model and you go to the coefficient and statistics, coefficients, and so you have the intercept and the coefficient. So the intercept is C, y equal to mx plus c. So I'm essentially finding the equation, which is sales equal to certain coefficient multiplied by the ad spend plus the intercept. Okay, C. So sales equal to 0.053 ads multiplied by ad spend plus 4.49. That is the best fit equation that the dictation learner has figured out based on the training data set. But I'm not really interested to find out the R square, even though there is something called R square. Okay. By the way, there is something like T value and probability greater than T. Is anybody aware of this in the statistics? You should have studied T value and P value. Anybody remembers what is a P value? Have you studied something called a P value?
Yes.
Yes. So what
Yes,
is the
sir.
meaning of a P value? What is the meaning of a P value?
The probability
It
of
signifies whether, okay, go ahead.
Sorry, no, go ahead.
yeah,
Anyone
please
else?
go ahead.
This signifies regression model is whether it's significant or not statistically.
Yeah, what does significant means?
For example, if the coefficients of the regression model, whether they are significantly affecting the model or not, this it will tell slopes. Yeah.
Coefficient means talking about ad spend. They're talking about the ad spend or something. The coefficient here is 0.053. So what is the meaning of that being significant?
The probability is more than 50% of spending the ads will result in sales.
No. Here nothing is to do with 50%. Okay, that is more for classification problems. See, p-value is used to accept or reject a null hypothesis. That's the purpose of p-value. If the p-value is less than 5%, that's the convention, 5%. It can be 1% also, but usually in industry, you take 5%. If the p-value is less than 5%, you reject the null hypothesis. And if p-value is more than 5%, you accept the null hypothesis. But the question is, what is the null hypothesis here? Here you can see p-value is 0. That means you are basically going to reject the null hypothesis, provided you know what the hypothesis is. So what hypothesis are you rejecting? What is the hypothesis? P-value is used to accept or reject a null hypothesis. Okay. If the p-value is less than 5%, you reject the null hypothesis. If p-value is more than 5%, you accept the null hypothesis. So what is the null hypothesis here? Anybody?
The amount of cost spent for ad
Hmm.
Is directly proportional to the sales.
No, null hypothesis is never formed like that. Okay. If you have done in statistics how null hypothesis formed, null hypothesis is always formed something is equal to something. And alternate hypothesis, which is rejection of the null hypothesis, is something is not equal to something. Null hypothesis is never formed the way you made the statement. Okay, that's not how null hypothesis, that's not the definition of null hypothesis. Null hypothesis means that apple is equal to orange. That's null hypothesis. Alternate hypothesis, apple is not equal to orange. And based on some data, you prove that the p-value is less than 5%. So apple is null hypothesis rejected. That means apple is not equal to orange, and hence hence null hypothesis is rejected. So apple is not equal to orange. Okay, so meaning of null hypothesis is you have to formulate a null hypothesis which says something is equal to something. So what is equal to what in this case? And if I say the null hypothesis rejected as in this case, that means whatever is equal to whatever is not true anymore.
As a general assumption, we can say that increase in ad spends will.
No. That's the general. But in statistics, how do you formulate? Because why it is important is because when you are talking about p-value or null hypothesis, these are statistical concepts. Okay, so we cannot generalize it. There's a specific meaning to this. Okay, it cannot be said in a commonsensical. It has to be said in a technical way. Okay, and that's important because otherwise it will be confusing for you to understand what exactly is the meaning of this. So don't do it generally. Understand technically what null hypothesis means because you've already done a statistics course. So you should know what technically null hypothesis is, what technically p-value is, not a commonsensical. So here the null hypothesis means something is equal to something. What is equal to something? The ad spend, the sales without ad spend is equal to sales with ad spend. That is the null hypothesis. Sales without ad spend, the amount of sales I'll achieve without ad spend is equal to the sales with ad spend. In other words, ad spend does not affect sales. But you cannot, technically you cannot write a null hypothesis saying that ad spend doesn't affect sales. You have to write it, something is equal to something. Ad sales without ad spend is equal to sales with ad spend. Is this clear? Yes or no?
Yes, Professor.
So, which means the alternate hypothesis is sales with ad spend is not equal to sales without ad spend. It's not saying sales with ad spend is higher or lower. It's just saying when you have ad spend, the sales that we expect is not equal to the sales then we don't have ad spend. And because here the p-value is less than 0, we are rejecting the null hypothesis that sales with ad spend is equal to sales without ad spend. In other words, the outcome of this learning model says that there is a dependence of sales on ad spend. If it was the other way around, that means if the p-value was greater than 5%, then it indirectly means that, or not indirectly, in fact, it means that the ad spend has nothing to do with sales. Then obviously there's no question of predicting sales based on ad spend because anyway ad spend is not affecting sales. So it also determines what is the utility of the feature which you are using to predict the outcome. We are trying to predict the sales based on ad spend. The assumption is that ad spend has an impact on sales. Now, what is the proof of that? Only if the ad spend has an impact on sales, then only there's the use of predicting sales based on ad spend. Otherwise, it may give actually a wrong prediction. So this is what this information is giving. Okay, so far fine, everybody? Clear? Yes or no?
Yes.
Okay. Now I need to, since I know that there is a the use of ad spend on sales, I will use this model, which is this equation, and put it in the test data set and see what is the outcome and what is the variance. Okay. So now I will use linear regression predictor. Regression predictor. Now we don't need a separate linear regression predictor because once we have an equation, we need a linear regression learner because we need to say whether it's a linear regression or it's a polynomial. But once we have the equation, the same predictor can do both the job. So the equation goes here, the data goes here, and now I'm going to predict. So what I'm going to predict, so I can just give a name to the predicted, let's say I call it predicted cells. Now the model will not know the actual cells of the remaining data, and it will predict the cells, and then I will compare. So here I have the output. So let's say the first row, the sale is 7.2 and the predicted sale is 11.6. So the model has predicted that given this ad spend, the sales is 11.46, whereas the actual sale is 7.2. Similarly, the second one, the model has predicted the sale is 10.472 and the actual sale is 11.8. Now, obviously, I cannot go one by one and estimate what is the error. What I should do now, I should calculate the R square. A high value of R square will indicate that the model is a good fit for the training data set. For the testing data set. Training data set, the model will always be a good fit because it will always find out the line that has the highest R square. I'm not interested in knowing the R square of the training data set. I'm interested in knowing the R square of the test data set. When an unknown data is given to the model, how well has the model performed? Okay, so I need to calculate the R square of the test data set. How will I do that? I will use that as a scorer. So there's something called a numeric scorer. So this scorer is used typically for classification problem. We typically use this numeric scorer over here. And we will configure this numeric scorer. So reference column is sales and the predicted column is predicted sales. Okay. And so I'm going to compare these two and find out what is the R square. So like this. Okay. Run this. And now we get a R square value of 0.86, which is not great, but reasonably good. Okay. So we see that it has been able to predict the sales based on ad spend reasonably well. Okay. So far, fine, everybody. So I think what you need to do if you're using your using the version that Bosch has is available with Bosch. The problem is that the names of these nodes are different. So unfortunately, you have to go to the documentation or you can even Google that. Let's say the version that I am using is 5.4.1, I think. Okay, so what is the name of the node for partitioning partitioning a table in the version of the KNIME that you are using. So unfortunately, there is no other way but to figure out the equivalent nodes in your version. I think it is a fairly, probably a little older version, because otherwise, if it is a little one version here and there, then normally you don't see a problem. Okay.
Professor,
Can somebody?
I found out the problem. There's a
Yes.
filter option where we had
Oh,
selected.
acha,
We had
acha,
to
yeah,
select
that's
more.
another problem. Yeah. Okay,
Yeah,
good.
so
Yes, yes.
I think
Yes,
maybe if we, Saurav, you can share maybe one round if we redo through him, it'll be a revision for us.
Yeah,
It'll be helpful.
just quickly share, then yeah. You have got the filter option?
Yeah, in the filter settings, we have to select.
Yes.
Yes. Actually, I was also trying out some other things here. So I just gone into the
And
I will
try
say
and
that.
see if you can change this in the, not the dark mode, because the dark mode is all there. I know there was a filter option, but many of the icons are not visible in the dark mode. So see if,
understood, sir.
so the filter option was not very visible. So I'm not sure whether you will be able to change it from the front end or not. Otherwise, you can tell your IT to change the settings to light mode.
Just a minute. I'm just restarting.
Yes.
Because I had gone for the classic version. I thought ki, let me
Yeah.
find
So
it
it
out
is,
over
see,
here.
your build is March 27, 2024. Okay. So it's not very
Yeah.
old, but slightly old.
Correct. And this is something else.
Go to
Sorry,
preference.
sir.
Preferences.
Sorry. Just a minute. I'll go for that. Yeah. Over here.
You can
Now
start
can you see?
doing that. Yes. You can start with CSV reader.
Yeah. Done. Add the file also. Just a minute. I have to add the file. Actually, I
Right click
missed it.
configure. No? Browse.
Yeah, just browse the file.
Yeah.
Execute.
Okay, done. Then I'm going into the scatter plot. Then I'm going to. Yes, then Rajesh, from here.
Here,
we
if
need
you
to-
type, see here, the filter, change the
Filter has
filter
to be
settings.
removed.
Change the filter settings.
Change the
change the
filter
filter.
settings on. Yeah.
Scroll down. Scroll down little.
No, scroll
Sorry,
down.
sir. Scroll down.
Scroll
Okay.
down.
Change the filter settings.
Yes,
Okay.
change
Here,
Make
all
it,
nodes you have to select.
all nodes here on right hand side.
Now, in our case, it
Now,
is partitioning.
Partitioning. Yes.
table is not there, only partitioning.
The scatter plot, and then we have to connect it from.
Scatter plot
From
you
the
pull it
column,
down.
from the column filter. Okay, scatter plot is like bring down, there's no output from that.
Partitioning. Configure.
To 70%. Okay.
Yeah. This is okay.
Yeah,
Here little bit settings is different what you have shown.
yeah. Random seed, like use random seed, you can take it on. Use random seed.
Last.
Last.
Yeah.
Apply,
Okay.
execute. Now you take
Yes.
the linear regression learner.
Type linear.
Linear. So
Yeah,
here you have it. Take the first node.
And the
Just go to
second.
the setting. Now go to the settings first. Run this first. Configure. So yes, the target is, so here the target is incorrect. Target is sales. You have to change the target to sales. Okay. Yes. Okay. Apply.
Okay.
Now run this.
Execute. Done. Then we have to do regression.
Predictor. Just search for regression predictor. Yeah, regression predictor. Take the and take this other data. Yes. Right. And just go to the configuration. Yes, you can change the name if you want. Predictor cells.
So what name shall we give?
You think that to appropriate predicted cells. So you can just keep predicted cells. You're predicting the cells. Doesn't matter. Anything that is, run it. Yeah, the predicted cells, and you can go to the statistics and check the, and now go to, and the last node is scorer. Select the scorer. Yes. Go to the numeric score. Numeric score, not the configure. So you are comparing sales with predicted sales. Reference column is sales. Apply. Yeah, that's apply. Execute this. You see the R square is 0.885.
Table form. Okay.
Yeah. That completes the pipeline.
Understood.
Okay. So great.
Okay.
So next class, we are going to look at multiple linear regression, where we will see the television, newspaper, and all the three other, not the total ad spend only. And we'll build the same pipeline and see how it works. Also, after that, we'll see how it can be done in the Colab notebook in Python. Not by writing codes, but by providing prompts. Okay. Fine. So see you then in the next session. Bye. Bye, everybody. Bye.
Bye. Thank you, sir.
Thank you. Bye.